This is the new Lenz LRB08 feedback module. It's a building block that allows you to put in train detection on a layout so that a computer program can control it. Each of these LRB08 modules can monitor 8 track outputs, and it just provides occupied or vacant information back to the system and then back to the computer. And the computer can make decisions about how the train operates. The way the train detection works is tried and tested. Each output is just basically detecting if current is flowing. So it can then recognise that there's a locomotive in that section or a vehicle consuming power. That then provides a occupied signal back to the computer. And that's all the computer program needs to automate. The beauty about model railways is that they are linear systems. If the route is set correctly, then that train is going to arrive at its destination. And as soon as it does, the destination flag is occupied and the computer will stop it. You need each block section where you want something to change. So if you want the train to start, stop. And if you want it to change speed, say at junctions, that's the main sort of monitoring that you would need to put in, the basic monitoring. And then the computer can work it out for itself. So I've got the module set up just for the demonstration here. So on this side of the module, you've got the connections back to your main command station, your Lenz command station. J and K go back to the track feed. In this case, it is critical that they're the right way round, J and K marked on the back of the unit. Keep those two wires the same. And the same with R and S, which is the feedback connection, the feedback bus. Again, R and S, the orientation of those should match what you wire it into on the back of the unit to get the best result. On this side of the unit are all the outputs. For a small layout, you actually only need to wire one wire from J. All these are linked. And what I've done here is the wire to this track, which is the solid track, the uninsulated side. Each of the sections I've got an insulated join. In this case it's just an air gap. I've just cut through the rail for the demo, but you'd put a plastic rail joiner in there to prevent it closing up. And then another section here where I've done the same, there's another gap. And then this wire from the first section goes back to K1, second section goes back to K2, and the third section to K3, and so forth. So on and so forth. You've got a large area to cover. You may want to run, where I've got it here, K2 and J are very close together. To get the best result over a long section, you might want to put another J in here opposite this one, so that the unit is measuring the current consumption as close together as possible. But for a small layout, you'll get away with just having the one connection to J, which is the far rail, the uncut rail. Again, follow the wiring in the manual. It's a little bit of a tongue twister to describe, but it makes all sense when you're planning your layout. With it all connected up and powered up, I've got it on the factory address, so it's on box number 65. If I put loco in section 1, lights up, move it down to section 2, there, and continue down to section 3. Oops, not doing this the best way. Your wiring on your layout will be an awful lot tidier than this demonstration. So yeah, so it's basically detecting that something is consuming power in that section. So a quick note about addressing the units. The address is for the whole unit, and then within that address are the 8 feedback sections. on the factory address they're delivered as 65. The original convention was that address 1 through 64 were reserved for the LS100, and that did point position sensing. If you're not using that, there's nothing to stop you using this as address 1. The total address range is 1 to 128, which gives you 1024 potential monitored sections. So yeah, that would probably cover most people. Programming it, there's two methods. I'll show you the quick method. The other method is to put it on a programming track and say change CVs as you would with a loco decoder, and there's a table in the manual to explain what to do there. But the quick programming, or programming while in situ, is using a push button. So to do that, we're going to send it a point command, not a feedback command, a point command. So if I wanted to change this to say feedback 80, I'll go to my handset, go to the turnout address, type in 80 and then confirm that. So we're ready to set up to switch point 80. And then on here we will hold the button until the red LED comes on. Takes a few seconds, now it's on, and what we're going to do is just use the M button to switch that point. Just do it once, LED goes out. I can then escape out of there, go to the menu, feedback showing, and we should now be detecting on address 80. Yeah, so it's saying section 2 is active. Take that off. Section 1. Yeah, so we've changed it to address 80. And then 1 through 8 will light up if they're occupied. I'm going to quickly show the same procedure using the older LH100. So at the moment I'm just showing it's currently on feedback 80 or Ruckmelder 80. On here what I'm going to do is press the F button and then use plus or minus to cycle it around until it gets to the point switching SW. And I'm going to put it back to the factory setting 65, enter. So we've got that preset ready to switch a point. Press the button again. Lights on, and then plus or minus to switch the point. There we go, light's gone out. Quickly go back into here, scroll back round to RM for Ruckmelder, and we put it to 65. There we are, so it's now detecting on feedback 65. Section 2 once again is showing. So one advantage of this style of feedback is it will detect something that's consuming power on a track. It doesn't need any transponders or anything like that. Got a coach here with interior lights. As I draw it through the sections, we trigger each in turn. Where it triggers can be reliant on how the coach is wired. So in this case we've got pickups off one side on one bogie and the other side on the other bogie. So it's not until the trailing bogie crosses the section that the section is triggered in one direction, so you have to be slightly careful of that. Just be aware of it, in fact. And I've noticed a wagon I had with just a single LED red tail light wasn't drawing enough current to trigger a response. So again, it's just worth checking out your stock to see which ones do trigger the feedbacks and which ones don't.